Special report. I'm Jerika Duncan. Thank you so much for joining us as history is being made. The members of the first crewed flight to the moon in more than 50 years are about to return to Earth. In less than 40 minutes, the Artemis II team will splash down off the coast of San Diego. This will cap a successful 10-day mission that took Commander Reed Wiseman, pilot Victor Glover, and mission specialist Christina Cook and Jeremy Hansen further than any human has ever traveled. In total, from the start to the finish, their flight will be estimated at 694,481 miles. There was another part of this history that was made on this flight as well. Cook was the first woman on a lunar mission, Glover the first African American, and Jeremy Hansen the first Canadian. Minutes from now, the entry sequence will begin. The Artemis II crew will eventually enter the atmosphere in the Orion capsule at nearly, get this, 24,000 miles per hour. And if that is not big enough for you, the heat shield on re-entry will endure temperatures as high as 5,000 degrees Fahrenheit. This 10-day mission has been a technological and scientific success for NASA, but also captured the attention of the world with breathtaking images of the moon we have never, ever seen before. Artemis II is an important step in NASA's planned return to the moon in 2028 and the eventual goal of building a base there. Senior national correspondent Mark Strassman has been covering the entire Artemis space program, and he is at NASA's Johnson Space Center Mission Control for the Artemis II crew. Mark, walk us through what is happening and how you are feeling at this hour.
Well, I'm feeling hopeful and fingers crossed, of course, that it all goes well. I want to walk you through, Jerika, the next milestone in this re-entry process that is critical, and that is the separation of the service module and the crew module. The service module sits underneath the crew module. 4 bolts are going to fire that will separate the two. The service module will plunge to Earth and burn up in the atmosphere. Why this is important? Because once the service module is gone, it exposes the heat shield that's at the bottom of the crew capsule. The heat shield is so important because, as you just described, Jerika, the temperatures are going to be incredibly hot, up to 5,000 degrees. That's half the surface temperature of the sun. And the heat shield is absolutely crucial to protect the lives of the 4 astronauts as they plunge to Earth. They will be, when they re-enter, about 76 miles high north of the Pacific and southeast of Hawaii. And at that point, it will be about a 13-minute plunge to the ocean. The parachutes will come in 3 phases. It will gradually decelerate, of course, first very quickly, and then very gradually when the chutes open. But about 20 minutes from now, Jerika, we're going to have, with any luck, 4 astronauts who went deeper into space than any humans ever have, back here.
And Mark, that separation that you talk about, we're just seeing that happening right now. I want to go to CBS News space contributor Bill Harwood. This, as you know, Bill, is considered one of the most dangerous parts of the mission. During Artemis I's re-entry, there was a problem with that heat shield. How did NASA adjust for this mission? What changes did they make?
Well, it's interesting, Jerika. When we saw separation, we just saw that heat shield for the very first time as the capsule pulled away from that service module. During that first flight, they were surprised to discover some damage to the heat shield. The capsule made it down safely. There was no one on board, but had there been anybody on board, they would have been fine. But they weren't expecting that damage. They spent more than a year investigating this, carrying out extensive tests, and they ultimately decided it's safe to come in again with the same heat shield by using a different trajectory. It kind of comes in like a stone skipping on water. It comes down, bounces back up off the atmosphere, and then comes down again. The damage was related to it coming back up out of the atmosphere and this heat shield cooling off more than they thought, and that led to that damage. We had a heat problem down deep. This time around, they're still going to do a tiny skip, but not much of one. It'll keep the heat shield hot. That's what allows the thing to work properly and prevent any damage from happening. They're very optimistic. This is all going to work flawlessly, but as Mark said, it's a nail-biting moment, no question about it.
Yeah, I think we can all feel that right now, and just waiting for that 8:07 to approach, and prayerfully everything goes according to plan. Joining me here in New York is former NASA astronaut Sunny Williams. She completed 3 missions aboard the International Space Station. Sunny is second on the list of cumulative time in space by a NASA astronaut with 608 days in space. Sunny, you've gone through this yourself. Just give us a sense of what the astronauts are thinking right now and what you're feeling.
Just to quickly talk about Reed and Victor and Christina and Jeremy, I think they're pretty excited right now.
Yeah.
That milestone that just happened, the separation, everything needs to go as planned, and that's like the first step of really just starting to come home, as the timeline indicated, you guys have mentioned before. So they're excited, they're in their seats, they're all strapped in, they're probably getting ready, talking about they're going to start to feel, gravity before too long, and that allows you actually to tighten down your straps, because before that you put your seatbelt on, but you're still sort of floating.
Right.
So they're probably anticipating this is going to happen before long, and just get themselves buckled in as good as possible as they start to do the re-entry into the atmosphere. So they're pumped. I'm sure they're excited. This is sort of the end, but also a very exciting time. I'm so excited for them. This has been an amazing mission. 10 days of just one awesome thing to see after another. I mean, it's just awesome. I have a little piece of, a little jealous inside of me, like, man, I wish I was up there. I wish I was being able to do that. That's so cool. But I'm so happy for this generation of astronauts to be able to do this and open the door for us, being able to be sustainably on the moon. And this is just cracking the door open to that, and to lead to so many more discoveries as we pave our way, getting closer and closer to going to Mars.
Yeah, I know before we went on air, when I asked you, do you miss it? Do you wish that was you in there right now? And you said yes, absolutely. I want to bring in another distinguished former NASA astronaut, Brigadier General Nick Hague. General Hague has completed 2 missions on the International Space Station and is now the Assistant Deputy Chief of Space Operations for the United States Space Force. Nick, you also experienced splashdown, one with Sunny, actually. Describe what this experience is like for you, and especially those who have experience being in space.
Yeah, at the end of a mission, it's the huge exclamation point. It is exciting, and Sunny nailed it in her description. It is a dynamic ride that has, as you start to re-enter the Earth's atmosphere, you start to feel G's that you haven't felt in a while, and then all of a sudden your heat shield starts to work, and outside the window you're watching bits and pieces of your heat shield burn and streak by, and you're inside this ball of fire, and then that culminates with slowing down, and chutes come out, and all of a sudden you're bobbing in the water. It is, for the crews, it's that first moment in the mission where they can effectively relax a little bit, because there's not much left for them to do. Now it's just the recovery forces coming to get them out of the capsule.
And we're going to come back to you in a second, Nick. CBS News national correspondent Carter Evans is actually in San Diego, where a United States Navy team launched from one of the Orion recovery positions. Carter, how big is an effort? How big is that effort right now?
The recovery effort is huge, and nothing about it is improvised. They have been practicing this, the team that is, they've been practicing this for years. All right, so this is the USS John P. Murtha. It is an amphibious docking ship. So basically what it does is it has a wet deck on board, it has a helicopter pad, it has a medical bay, all the communications they need. And what they've been doing over the last couple of years is practicing this, every possibility, over and over and over again. When it hits the water, what's going to happen after that? Who is going to be the first person to open the door? Who is going to be the first astronaut out? What is the plan? They've been practicing that for quite some time. What they have also been practicing is recovering the capsule. Once they've safely got those astronauts out of the capsule and onto the ship, they want to get the capsule onto the ship. Now, I mentioned that this is an amphibious ship. It has a wet dock. It's essentially like a garage, and they've practiced this over and over again as well. Getting that capsule into the garage, they say it's like pulling a car into a garage, and we're going to get a look at it coming up in just a little while.
And we can't wait. And someone who knows all about that, Carter, is retired Lieutenant Colonel David Mahan, also joins us on the set. He's the former director of the operations for the group tasked to recover and rescue astronauts astronauts, David. How will the operation work once the Orion capsule splashes down? We heard a little bit from Carter, but you have that know-how. Tell us what we can expect to see.
Absolutely. So I would say you're going to see what is the definition of a team. So the partnership between the military and NASA and all the different agencies that are involved in this, they've been practicing this for years. So the capsule is going to splash down. The ship is going to be about 2 nautical miles away from that. And one of the teams that's behind the scenes that people don't get to see a lot is the weather side of the house. So they're going to be releasing weather balloons because the ship wants to get as close to that splashdown as they possibly can. Obviously, taking into account the debris that's expected to fall off to keep the aircraft and the ship safe. So once they do that, they're going to approach the capsule. They're going to check for hazards to make sure it's safe to approach. Open the hatch, do the initial medical check on the crew, and then they're going to start extracting them. They're going to take them out on a front porch, and then they're going to hoist them and take them to the ship so they can get med checks.
You say this with such ease, and you're so calm. You have so much confidence, though, in the science and the practice and the years of training. Talk to us a little bit about that.
So absolutely. So the teams that have been doing this for years. So professionals, experts at what they do. It's been a partnership with NASA and the military, with the National Guard, with the reserves, with the Air Force, with the Space Force, with the Coast Guard. I'm sure I'm leaving some out, but it is really, truly a joint effort with a team of professionals. They're there and they know what they're doing.
All right. We look forward to seeing that teamwork at its finest. I want to turn now to CBS News meteorologist Rob Marciano. How does the forecast look for Artemis 2?
Well, first of all, it's so great to have you guys on set because you're calming us down. Because Jarek and I are very anxious about what's about to go down tonight. I'm not so anxious about the forecast itself. It looks pretty good. We got this big event, so let's go to the big wall here and talk about it. You know, it's not your typical San Diego weather for April, which would mean crystal blue skies, high pressure control. We actually have a late season storm that's hitting Northern California right now, even bringing some tornado warnings to the Bay Area. Luckily, the troughiness and the cold front is far enough back to where it shouldn't interfere. But you can see we do have some clouds at the lower levels and at the upper levels. That might limit some of the visibility, but what we saw there from the boat or from the ship, it looks pretty good. Can you believe this thing starts its entry at 2,000 miles away, out near Hawaii, and then slows down from 24,000 miles an hour down to a landing here just about 15 miles. The way they calculate this is amazing to me as well. All right, so water temperature, 65 degrees, about the air temperature as well. Wind 7 miles an hour, that's important. Waves now up to 5 feet, all right? So some of the criteria with this is that you can't have waves greater than 6 feet. So that's, again, that's more so for the safety of the crew and the rescue crews trying to get the guys out of the capsule there. So that's still what we think is going to be happening here. We do have a little bit of a cloud cover, mostly east towards the landfall there, but weather does look to be okay. Certainly could be worse. They can't have any rainfall, right? Because I would imagine the rainfall would knock down the parachutes.
Yeah.
That wouldn't be good. That doesn't seem to be an issue. But I'm very nervous about the re-entry before those chutes open.
Yeah, I have to say, even just flying.
Thank you.
I know that.
Don't worry.
Because even just flying in a plane, sometimes you worry about turbulence and all of that. To hear 24,000 miles an hour coming in, back to Earth, it's like, how is that possible? It's really amazing. As we wait, though, for the crew to return to Earth, let's take a look back at some of the sights and sounds of this historic mission around the moon.
We are going for all humanity. Your Artemis 2 crew is go for launch.
3, 2, 1. Booster ignition. And liftoff. The crew of Artemis 2 now bound for the moon.
Core stage separated.
We have good separation, good motion.
Your Integrity crew is go for TLI. With this burn to the moon, we do not leave Earth. We choose it.
Integrity looks like a good burn. We're confirming.
We surpassed the furthest distance humans have ever traveled from planet Earth. And our crew would like to propose a couple of potential names for those items or those areas. We lost a loved one. Her name was Carol, and we would like to call it Carol.
Integrity and Carol Crater. Loud and clear.
As we prepare to go out of radio communication, we're still able to feel your love from Earth.
Houston, we have you the same, and it is so great to hear from Earth again.
This is, continues to be unreal. The sun has gone behind the moon.
You are special.
in all of this emptiness, this is a whole bunch of nothing, this thing we call the universe. You have this oasis, this beautiful place that we get to exist together.
The four of us having been there just now, this is nothing short of a miracle.
And back here with us, former NASA astronaut Sunny Williams. It doesn't get old. I see you tearing up as we were watching.
No, it never gets old. It's really, really cool because you know that these are your friends that are on board. So, no, I'm not nervous. I'm just really excited and really happy for them. I know that this, like we mentioned before, this is a huge team effort over, you know, a decade working on trying to make sure that, you know, everything, all the T's are crossed, all the I's are dotted. They changed the entry profile just to make sure, because of the heat shield issues on the previous flight, to make sure that they're going to get back. So, yes, emotional, but in a really happy way.
You feel like part of your soul is with them on that.
Oh, absolutely. I know all those guys very, very well. Got to be actually on the selection board for a couple of those astronauts, the Americans, and of course I've known Jeremy for a long time as well. So I've known them as baby astronauts and seen them grow up, and hopefully we gave them some good lessons along the way.
If you look at your screen right now on the far left side, well, actually the full screen, you can see the images of the astronauts there. And we just heard from NASA that they said everything is in excellent shape. So thumbs up there as we continue to see and watch what is happening and watch the people. I mean, you can see folks outside smiling and just so excited. And Rob, I know you got a chance to be in the midst of that, talking to the young people. I think you got a little choked up.
Oh yeah, you can't help it. It's a different vibe now. You know, we went from a launch where people were gathered around the launch pad itself, or in view of the launch pad, or even launch parties around the country, right? Watching this thing go up, and it was a very communal event, you know, and once it went up, it was joyful, and you were just in awe of the whole spectacle, and cheering them on, and sending sending your kids off to school or something, you know, hope to see you on the way back, right? But now it's a different vibe. I mean, it's great to be with everybody here, but we're kind of now witnessing it, you know, a little bit more secluded, right? Maybe in our living rooms at home, watching on TV. But probably the biggest groups are at Mission Control and on that ship right now. So it's definitely a different vibe, and one that's hopefully we'll be celebrating here in just a few minutes.
I want to turn back to Nick Hague there in Washington. What part of the mission stood out to you, Nick?
Well, when I was glued to the feed when they were doing the lunar flyby, just, you know, knowing them so well and being able to watch them on the stream from the capsule and see their body language and the excitement, I was riveted. So that 6 hours, I couldn't stop watching. And then to see some of the first images that they were able to transmit down in high definition of the moon with the Earth in the background, it's just so captivating. It's so exciting. It says, you know, this is the beginning. And that's what this is. This is, you know, a test mission that is paving the way for follow-on missions so that we can get to the moon and establish a base on it and continue to explore.
We see some of those pictures beside you right now of the moon, the pictures that we had not seen before, those craters, and I think so much of what this exploration represents is the future. I want to turn to senior national correspondent Mark Strassman. He's at NASA's Johnson Space Center. Mark, if you could touch on the developments, the exploration, the advancement in technology, and where ultimately this gets us closer to.
Well, remember, this is the first lunar mission in more than a half century. It's the dawn of really a new lunar era for NASA of human exploration. Haven't been there since 1972 in Apollo 17, and this is the next step to an eventual moon landing, which would come with Artemis 4, which NASA has scheduled for early in 2028. I'm just also struck by how far this crew has come. I mean, physically, that is, remember just 4 days ago, they were another 250,000 miles in deep space, further than any human being has ever gone before. But then just as people, I mean, we were all touched and moved and stirred by some of the images that they sent back to us of the solar eclipse and the far side of the moon and Earthset. And you could tell how touched they were too, that even though 3 of the 4 of them were experienced astronauts, had been into low Earth orbit with the International Space Station, this was just a different experience and a different perspective that they shared with us through their pictures. And it was sort of remarkable to experience vicariously through their eyes and through their interpretation of events. And it really, I think, opened the eyes for a lot of people looking on. Remember, Jerika, that 3 of every 4 people on planet Earth alive today were born after Apollo 17. So this is their first time witnessing any person go anywhere near the moon. And this will be something that they will always remember. And can you imagine what it's going to be like when we have a moon landing? I mean, you think the excitement here was huge. I mean, that one will be through the roof.
Yeah, and we're watching the live pictures right now from Artemis as they're getting closer and closer to Earth. I want to go back to CBS News contributor, space contributor Bill Harwood. There are ambitious goals, absolutely, for the Artemis program going forward. What are they, and how likely are we to see some of those goals, that meet what they want in terms of getting to Mars, or, companies being able to do things that they're not doing now? How close are we to that next phase?
Well, it's interesting, Eureka, the Artemis moon program right now, the plan calls for a flight next year to test docking and rendezvous procedures with moon landers in Earth orbit. The landers are being built by SpaceX and Blue Origin. If they get that worked out in 2028, NASA wants to land 1 mission, if not 2 missions on the moon, put boots on the moon near the moon's south pole, and that's going to lead to what NASA Administrator Jared Isaacman says will be 2 moon landings a year as the agency begins building a lunar base near the South Pole. But I got to tell you, that's assuming successive administrations, successive Congresses provide the funding for all that. Isaacman is optimistic, but a lot of Americans look at the moon as we've been there, we've done that. We won the original space race back in the 70s or the 60s and 70s, and might not see the value in spending that kind of money to build moon bases and that stuff. But the agency wants to do that. They view the moon as a stepping stone to Mars, and so that's the logical next step.
All right, again, we're looking at the live picture, and we just see it getting closer and closer very quickly, about 20 minutes away, potentially from splashdown. Joining us now is Jana Levin, a CBS News contributor and professor of physics and astronomy at Barnard College. Professor, what do you think the impact of this mission will ultimately be?
Well, we're back in our journey exploring both the solar system, but also, in some sense, more of Earth. It's thought that the moon is actually part of the Earth, that there was this cataclysmic collision 4.5 billion years ago when the Earth was forming, and that material, some of it fell back to Earth, but a big chunk of it became our moon. So in some sense, I think we're really expanding our horizon of what we think of as home.
Across the threshold now.
And again, looking at those live pictures, getting closer and closer, Jana, the Artemis 2 crew, they are now roughly 400,000 feet above Earth and about to make their first contact with the upper atmosphere. During this time period, they will enter a radio blackout for 6 minutes due to the plasma formation around the Orion capsule upon hitting the atmosphere. Let's take some time to listen in to Mission Control.
And as predicted, we've entered our communications blackout. This will be a 6-minute blackout period. No voice, no data from the crew. We're 30 seconds away from the anticipated point of peak heating on the vehicle, where temperatures will rise to about 4,000 to 5,000 degrees Fahrenheit. This is the true test of our trajectory. And from the G5 aircraft in the vicinity of the splashdown zone, this view of integrity. So that pinpoint of light shows the vehicle as it enters the period of peak heating in the Earth's atmosphere, the first tug of gravity being felt by Integrity's astronauts since their launch back on April 1st. 5 minutes until the end of the blackout period. Time to splash down, 11 minutes, 33 seconds.
That little dot was.
You are looking at what appears to be a ball of fire moving at a pace that it is not normal. This is a visualization, excuse me.
The landing and support officer
But this is essentially what is happening. Sonny, your reaction.
An exciting time. Obviously, we can't talk to the ground because during these time frames when we're coming in, because of this ball of fire that's all around us.
Yeah.
And the windows, they'll be able to see, plasma going by the windows that we do in all the other spacecrafts. You see the spacecraft sort of change color, around because of that outside of the window. So they're probably seeing some of that plasma right near as they're looking out the windows with, Reed and Victor right there. So pretty exciting time frame. You know what's going on. Like Victor mentioned one time in one of the interviews, riding a ball of fire into the atmosphere is a little exciting. But
what does it feel like? Are the G-forces, and then does it get warmer inside?
No, it doesn't get warmer inside. That's the capsule is made for that. The heat shield is made for that. This entry was made specifically knowing that they had some issues from before. And so, no, you don't feel the heat inside, but you can just see what's going on around you. You'll start feeling the G-forces since they've started coming into the atmosphere. So like I said, now they're getting a little bit pushed, and the G-forces change during the entry. So there's a couple times that it feels like it's pushing down on you, then it will let up, and it'll push down on you again. So you're coming home. This is an obvious time right now that you know that you're coming home.
Yeah, and Sonny, thank you for that description. I want to turn to former astronaut Nick Hague. Nick, what do you remember about the experience, and are you smiling at this point? Are you nervous? Like, what's the feeling as you're entering, back, getting ready for that splashdown?
Yeah, it's an assault on the senses. Sonny hit it right. I look out the window and you get this light show, which is amazing when you think about the physics behind the heat shield and how it slowly melts away and burns away and it brings you and slows you down. But you also get a lot of sound. You're out in the vacuum of space, and there's not a lot of sounds that you hear as you interface with the very upper atmosphere. But as you get deeper into the atmosphere, you start to hear wind noise, and you really get a sense for the speed that you're going. It's a pretty amazing ride.
From the crew.
Wow. Again, visualization. Although Rob and I both were like, oh my God, what's happening?
And you talk about this inferno outside your window like it's, an everyday thing. It's just, at any point during your mind when you go through one of these re-entries, do you think, oh, I hope this heat shield works here?
Oh, again, to talk about the team, a decade of people really crossing the T's and dotting the I's, making sure, we've taken all the lessons learned on spacecraft beforehand and incorporating into that. So we have a lot of trust. There's a lot of trust in this business and in our team to make sure that they do the right thing.
And is there any chit-chat going on during this blackout?
Oh, I'm sure. They're like looking at each other, and probably the color inside of the spacecraft's a little bit different because of the plasma. I remember on Soyuz, everybody looked a little bit, the whole inside looked a little bit pink because we have windows on the side. So yeah, I'm sure they're looking around and talking to each other about it.
Well, NASA is about to reestablish contact with Mission Control, so we want to listen in and hear what they have to say.
We are now processing data from Integrity. Landing and support officer reports the small boats are en route to the splashdown target zone. Passing through 150,000 feet, our trajectory is perfect. We're getting intermittent views of integrity. Still waiting to establish voice communication.
Integrity, Houston, comm check, post blackout.
Houston, Integrity, we have you loud and clear.
Your trajectory is nominal, and your recovery teams have visual.
Guys, looks good.
No action for the enabled internal camera controller fail.
Big cheers from the viewing room here in Mission Control as
Everything looking good as we're just listening to Mission Control talk about the data that they're already processing as the capsule makes its way to its splashdown. I want to turn to you, Dave, because now we're at the point where they're talking about the boats getting ready. Again, this is something that, you know, you've planned. This is years in the making. What's going through the minds of those who are there, and they're also getting this information in real time.
So as everybody's tracking everything, they're just executing what they've been trained to do. So it's game on for everybody there. Everybody's excited. Everybody's happy to hear from the crew now that they have contact back. And everybody's going to start moving closer and closer to the capsule and ready to extract the crew from the spacecraft.
And I believe, correct me if I'm wrong, that's what we're seeing right there, that first.
It is. So that is one of the small boats moving in. So everything is precise based on time. Mm-hmm. And as time goes on and debris gets tracked and stuff like that, they'll actually move closer and closer to the spacecraft.
Integrity impact to the camera controller fail is...
And right now the ship is headed in from one of their checkpoints as well to get closer.
When you think about what is gained from some of what we're learning and the idea of possibly being able to go even beyond the moon one day, why did it take so long?
Time to splash down 4.5 minutes.
Well, you know, we spent the last couple decades building the International Space Station and flying the Space Shuttle to learn about how we operate in low Earth orbit. And we've learned so much from that, that it's sort of opened the door. You know, of course, technology as it comes in computers, but also manufacturing, all of that has changed over the last, like, 3 decades and allows us to build these amazing spacecraft nowadays that allow the crew members to take those observations, which was, oh, there it is.
And then you have a NASA plane right now capturing Artemis 2, making its way down. Again, we know that the speed at this point is, I believe we're at about, I want to listen to Mission Control, but I'm not sure if we're at the maximum or if we've passed that period yet.
I think we're subsonic now.
You were subsonic, so they probably heard the boom.
Yeah.
I still don't hear it. There you go.
There's the parachute. Okay.
The first series of parachutes.
And we're about 4 minutes
and
away.
We're on drogues.
Yeah.
You hear people cheering.
Here we go. Yeah.
Drones out the window.
Look at that.
2 good drogue shoots. Next up.
We copy, we see them.
Next up, the deployment of pilot parachutes that will pull the main chutes out. Time to splash down 3 minutes and 10 seconds. Perfect descent rate according to flight dynamics.
Good rate on 2 drogues.
We keep the same on board.
Passing through 10,000 feet, still on drogues. Main chute deploy. We're at 5,000 feet. Search and recovery beacon has been activated on integrity. And we have 3 good main chutes. Good 3 main chutes, good reefing, good descent rate.
Rates, and we see 3 good-looking parachutes. Integrity. Cabin pressure indicates no need for hydrazine checks.
copies.
This is a perfect descent for Integrity. Its crew sounding hale and hearty on board. Time to splash down 1 minute, 15 seconds. Integrity about to complete a journey spanning 694,481 miles from its launch from the Kennedy Space Center back on April 1st, and a trip around the moon. Passing through 1,000 feet.
Integrity splashdown, sending post-landing command now.
Splashdown confirmed.
Copy splashdown, waiting on DLDR.
Splashdown confirmed at 7:07 p.m. Central Time, 5:07 p.m. Pacific Time. From the pages of Jules Verne to a modern-day mission to the moon, a new chapter of the exploration of our celestial neighbor is complete. Integrity's astronauts back on Earth.